This is release question number 27 for the California Standards Test release questions for the subject of one near and dear to my heart, geometry. Number 27 says this: what values of A and B make quadrilateral MNOP a parallelogram? And so what would have to be true about these? I know that this one would have to be congruent to this one. Opposite sides in parallelograms must be congruent. That's a property of parallelograms. This one would have to be congruent to this one as well. And so with these, you could plug in the answer choices into here. Honestly, that would be one way to do this since it's a multiple choice type test. But I want to show you how to do that without quote-unquote cheating like that, and to set it up the way you could solve it no matter whether the answers were here or not. So it's 4a plus b equals 21. These two have to be congruent, therefore they have to be equal in measures and lengths to each other, and 3a minus 2b equals 13. And so I noticed with that if I put these two together, if I combine these linear equations, linear combination method, nothing's going to cancel out. We could subtract 4a, that would be another way to go about this, and then say b equals 21 minus 4a. Plug that in for b down here, that would be the substitution method, and then solve for a from there. That's one way to do this. I think the slightly easier way in this case is to use this linear combination way. I'm going to multiply this one by 2, and this one I'm not going to change at all. So no change here. This one times 2. Let's see what happens. I need to multiply everything times 2 though, so it's as if I need to distribute the 2 to every single part. I have to change everything in the same way. So this would be 8a plus 2b equals 42, and this would be 3a minus 2b equals 13. Now if I combine these together, linear combination would say things would cancel out here. That was the whole point of multiplying by 2, was to get the b's to cancel out. Now if I combine these equations together, think of it like a scale or a balance in your science class. Maybe you've had something like that before. I'll just draw a quick little picture like that, where you're trying to get things to balance out. You put some weights on this side, some unknown object over here, and some weights over here. If you added the same amount of weight to this side, you'd have to do the same thing here. You'd have to add the same amount of weight to that side to keep it balanced out. So if I were to put both equations together, it's like putting all the weights together here with all the weights together here. If you had two equations that balanced out before with two more equations and just put all the weights together on one scale, that's like making one equation where they're true. So that's essentially what's going on here. I've got 11a now equals 55. If I divide both sides by 11, I get a equals 5. So it looks like my answer choice is B, but let's finish the problem and make sure that the lowercase b, the variable, actually equals 1. And so I'm going to pick one of these two equations to use. I'm going to pick this one because it's already solved, or it's already left in terms of just plain old b. I just need to get the a's on the other side. So I'm going to have 4 times 5 plus b equals 21. That's 20 plus b equals 21. If I subtract 20 from both sides, that's b equals 1. My answer choice, what I thought it was, held true, held fast. It is a equals 5 and b equals 1. You can plug both of those numbers back in. Let's mentally do that real quick just to check. This would be 20. 4 times 5 is 20, plus 1 is 21. And then 3 times 5 is 15, minus 2 times 1 would be 2. So 15 minus 2 is in fact 13. We got the right answer. 27, choice B.